weekly remote lab 30 sessions. Today we here have Madina Jelbuldina. She is going to talk about the material science and microfabrication facility in our university at the CB4 block. So Madina, good afternoon, hello.
Hello everyone, thanks for joining. As I've been said, my name is Madina and I'm presenting today our facility, which is one of the division of the big research center of Nazarbayev University, and it's located in the C4 building. Some people doesn't even know about our facilities, so today I'm going to talk more. Core Facilities is the big research center which is located in the C4 building, and it was organized into like 2 or 3 years ago. So it's housing different tools and techniques, and it's available to everyone. Like basically any student, any professor can book the tool and can use it for his research. And we have several divisions. Last week, my colleague Aydos Baymuratov talked about biotechnology complex. As well, we have analytical chemistry division, electron microscopy, which is scanning electron microscopy, tunneling, and Raman spectroscopy. And today I will talk about material science and microfabrication, which is also a part of our big center. We have a little video about
Excuse me, you're not sharing the video.
Is it okay?
No. You can just press share screen again and choose the other window, the browser. Yes. Now we can see it.
Thank you. So. So this is the C4 entrance. This one is a biotechnology research center in 6th level. So this is material science. This is called magnetron sputtering. This one is atomic layer deposition tool. So we have research engineers, Arman and Jenbek here in this screen. So the silicon wafer is put inside the tool, and the plasma is generated, and then the molecules of metal is deposited. And another one is the clean room. We have 1000 class clean room. This is photolithography, and I will be talking also about it. This is the Center of Analytical Chemistry. Scanning electron microscopy. This is tunneling electron microscopy. Okay, so let's talk about our division, which is, we have several labs. So one laboratory is dedicated to thin film deposition. What is thin film? It's the films of materials, like starting from several nanometers up to several micron thickness. And this is used to deposit onto different substrates, for example, silicon wafer, glass substrate, polymer, etc. In our laboratory, we have which is called physical vapor deposition and chemical. Physical means that the process doesn't involve any chemical reactions, only physical heating. For example, we have magnetron sputter system, and plasma is generated, and plasma is heating the target, for example, metal like titanium target or aluminum, and then the molecule is heating and evaporating onto your substrate. Another important tool is chemical vapor deposition, which is atomic layer deposition. Also, we have CVD Tube Furnace. Next direction is when your film is deposited. For example, you can characterize the variety of, for example, thickness of material and chemical composition. To do this, we are offer different techniques. For example, X-ray photoelectron spectroscopy, which has arrived only recently, and it's a very powerful tool which can give you elemental analysis of your material with a very high precision. We have X-ray diffraction spectroscopy. Then nanoindentation, it's to characterize mechanical properties. Then we have spectroscopic ellipsometer to define the thickness of your dielectric material, and the stylus profilometer. Stylus profilometer is can give you information about thickness of material. So next division, and it's important, is clean room microfabrication. It's now not completely open, so we are just open one photolithography laboratory, and we are working to build another instruments. So clean room is 1000 class clean room, which means that there is special ventilation system and there is very, very low concentration of particles. This is necessary to fabricate electronic devices, for example, transistors, solar cells, and other microelectronic devices. So I will talk today also about our laboratory, like UV photolithography. We have spin coaters and mask aligner from German company Zeus Microtech. These two material tools will be coming soon. Actually, we are building now gas systems. So it's also electron beam evaporators. So if you need metal, like very high quality and thin, for example, several nanometers, aluminum, titanium, gold, we will have nickel, basically all materials can be deposited. So first, let's start with the material deposition laboratory. It's located on the first floor, room number 142. This is magnetron sputtering. Magnetron sputtering is, there is the chamber where plasma is generated, for example, argon plasma. Then in plasma, there is two cathode and anode, which create discharge. So the plasma molecules, the gas molecules, they start like bombarding your target material. For example, metal, titanium target. And then after bombarding this target, the molecules of titanium start to evaporate inside this chamber, and then they are deposited onto your substrate. For example, people come with wafers, silicon wafers. Sometimes people use glass slides. So the advantages is that any kind of material can be deposited: metal, dielectrics, alloys. And however, there is the disadvantage. It's not, sometimes the film will be not uniform, and it's not as directional, for example, as atomic layer deposition or electron beam deposition. So on the current that we have, which materials is aluminum, copper, silicon, chromium, zinc, molybdenum, tungsten, titanium, and silver. So this information is available on the Q-Reserve system. You can book your date, your time, and then operator will help you to use the system. Okay, now the chemical vapor deposition. Chemical means there is some chemical reactions acting. So this tool, it's called atomic layer deposition. From the title, we can say that the material can be deposited as thin as one atomic layer, right? So we will have starting from several angstrom to nanometers. And this is especially useful to deposit dielectrics. For example, zinc oxide, aluminum oxide, hafnium oxide. To do this, but this is quite complex tool, and it's required special gases like precursor gases. So, and also precursors are expensive, and they require very careful maintenance. Also, another chemical vapor tool is the CVD Tube Furnace. CVD is a multidirectional, highly conformal deposition. And the advantages is a quick deposition, a good uniformity, high availability, and also it's not so expensive as the atomic layer deposition. The disadvantages is that the thickness cannot be so controlled. So if you need very, very thin, like several nanometers, this cannot be deposited with the CVD tube. Another tools is, another division is the characterization. So when you deposit your film, you need to know what is the properties. Is it good? Is it bad? Because if it's 100 nanometers, for example, you cannot even see it. To do this, we are offering different characterization tools. For example, XRD, which means X-ray diffraction. X-ray diffraction can give you information about what exactly chemical elements contain in your film. So crystal structure, film thickness, roughness. Then X-ray photoelectron spectroscopy, it is located also in the first floor, 111 room, and by Thermoscientific. So XPS give chemical information on elements, also on the chemical state, and very useful for the surface analysis. And then the nanoindenter gives you information about mechanical properties such as elastic modulus or hardness on bulk solids. Next, we have two more tools. This is located on the room 255 on the second floor. So first is DECTAC stylus profiler. DECTAC has the diamond stylus, which is like only 1 micron of radius, and it gives you profile about roughness of your sample. And for people usually use it to define the thickness of the material. Then ellipsometer. Ellipsometer is used for dielectrics. Dielectrics is oxides, for example, silicon dioxide, zinc oxide, to also to define their thickness and optical properties. Another division, it's located in the mezzanine floor, and as I said, we are in process. So now we have finished building our photolithography room. Photolithography, or another title is UV lithography, which is from the title you can say that there is some UV light. Yes, we have the UV light, UV lamp in this machine, and it's used to expose your silicon wafer. Actually, photolithography is the starting process in the microfabrication of semiconductor devices like field effect transistors, solar cells, and other transistor devices. So here is the diagram which shows how the photolithography works. So first of all, like you know that any semiconductor industry starts with the silicon wafer or some other semiconductor. So we take semiconductor wafer, then we spin coat photoresist, and then using this machine, mask aligner, and the special mask, the ultraviolet light is exposing the substrate. So photoresist is the polymer, and under exposure of UV light, it will be dissolved. So on the final state, you will have the substrate with some pattern of your photoresist. Then you can do your metal deposition, and for example, if you need to have electrodes on your device and other processes. So also in our laboratory, first of all, you start with the cleaning of your silicon wafer with acetone and isopropanol. This is very critical because even a tiny particle like 1 nanometer particle can destroy your device, and your transistor will not work. So the important stage is cleaning. Then using this machine, it's called spin coater. You put photoresist on the substrate. A photoresist is special polymer, and as I said before, photoresist is sensitive to ultraviolet light. And then after you spin coat, the spin coating also have different parameters like speed of your spin coating, then time. All this combination will affect your device. So depending on your structure, this can be, and with the help of operator, me or my colleague, we will help you to define good parameters. So then the wafer is exposed in the mask aligner in this machine. And then you will use special special solution to remove. So for example, the photoresist will be partially removed and you will have structure. And then after you get your structure, you can use microscope to check if it's good or bad. And then after that, other process can be done like metal, or you can do etching. And then finally you will have your device. So this is basically it. I will be happy to answer your questions if you have. Thank you for your attention.
Thank you very much, Madina. I think it was an interesting presentation. So first of all, let's cover an interesting point for all of our participants, I think, how to access these laboratories, how to get access to working with these machines.
So we have, can you see this site? It's called Reservation System. So when you should choose core facilities, and then first of all, you create your profile. Just regular like your email, but email should be a new email to be authorized. And then you will have access to the tools. For example, you can see like SEM, and then scanning. So here, scanning electron microscopy. You will have all information. For example, is it free or not? This is access reservation calendar, which gives you calendar about. So for example, SEM is very popular. As you can see, it's always booked. So you should choose the day when it's free. For example, next week. And then you can make reservation like you're from morning or like in the afternoon, and then you press reserve. So, and then the operator will approve, and he or she will come and help you to do your sample. Also, it's very useful to contact to contact our colleagues. There is this for example, you can send email to, for example, this is atomic layer deposition, and my colleague Arman, he is working with this tool. So you can leave message. For example, if you are not sure which material to choose or how to characterize your sample, and he or she will reply to your message. And And then you can choose the day when to do your sample. That's it. Like there is no special. One important thing is every tool has some restrictions. For example, in ALD, you cannot bring plastic because as you can see, the temperature is 350 degrees, right? So the plastic will just melt, and some other rules. For example, you cannot bring chips which are very small because the chips can fall down and it can damage the system, right? So basically that's it. Like we have we have 3 people, Arman, Janbek, and myself. You can find their in phone book. You can see their emails and just send email to ask your questions.
Okay, I see here in the chat next question. This is, thank you for the presentation. I have a question. Does your laboratory conduct offline or online courses on how to use the lab equipment?
Yes, there is always emails from core facilities. For example, right now we have 2 courses, optical microscopy and electron microscopy. In this course, first of all, we cover how to like physics or chemistry of the process, right? And then a little bit of how to use, but and basically, if you want to be self-user, like there is some option, you have to do practice, and then operator should approve you. But first of all, always with operator. You cannot come yourself because this is very expensive, like several $100s, $1,000 equipment, and if it's damaged, then we need to invite engineers to maintain it. First you do with operator, then operator can train you, like, and when you're always sure, like, okay, I can do it myself, you can come and use the tool. This is the procedure and this is the rule.
Thank you. And here we have a follow-up question from the same person. Do we need our mentors or PI's permission? So, or...
Okay, yes, when you do in Q-Reserve, when you do reservation, there is, you should write, here you see, like PI of the project, for example, his or her name, and then how many samples you have, like 1 or 3 samples, and then name of the project. That's it. Like specifically, there is no need of permission of PI. But of course, like if you're doing your research with your PI, I think he will always know what kind of things you're going to do, right? Because this is your project.
Thank you. So if you have any questions, please feel free to use the chat or the voice button. So we have here another question. It says, are there any current researchers in the lab?
Researchers. So as I said, this our core facilities is the center which provides us like service. We are not doing research ourselves. We have operators and we have coordinators who can help. For example, scanning electron microscopy, there is no other microscopy in university. So every person comes to our lab to do microscopy analysis. And if that's what you mean, like we are not doing research. But mostly in our facilities, who comes? Mostly it's electric engineering as major, then like yes, professors from physics department, where not a lot of chemistry people. Usually it's physics and electrical engineering.
Okay, here we have another question. Are there any restrictions on year of study? Yeah, I think it means like for the lab is only for seniors, or the juniors, sophomores also can have access.
Anyone, if you're doing research, for example, but I think like most research starts from capstone, right? Like in the 3rd or 4 years undergraduate. So if your capstone involves some like hands-on experiments in material science, yes, you can book, or you can discuss first with your PI, with your professor, and yes, you can use the tool. No restrictions. But then, like, for example, most students that come to our lab are master students or they are PhD. Yes, sometimes yes, undergraduate also. So, like, are you guys from undergraduate studies, or because I saw in email it was to master students also and to undergraduate students? So you are undergraduate, right? Yes, if your capstone will involve some characterization or electronic, yes, you can book, and you can send email before to me or to my colleague Arman to describe your target, and then we can organize something.
Thank you. So are there any questions left? Anyone? Don't be shy to ask any questions. Okay, it seems like they're okay. Oh, good to have one question. It was very interesting. Okay, it's not a question. It was very interesting. Thank you, from Alina.
Thank you for joining. Yes, as I said, even sometimes researchers doesn't know about our facility, maybe because we are not advertising a lot, but it's located in C4, and yes, it's open to everyone. That's what's the purpose. So like every student, every person can do research, and there is no basically restrictions. Like, I mean, it doesn't mean your chemistry, your physics department, anyone are welcome. And I wish you good luck with your future study and with your research as well.
Thank you very much, Madina, for joining us in this event of the remote lab tour sessions. Indeed, the session was really interesting. Okay, yes. One last question here. Does core facility have web page?
Yes, we have, but last time I checked, it was, I don't know, it was some problems, but it's, I will type here, it's cfnu.
Okay. Here, let me resend it for everyone. This is the website.
Website and in Reserve. In Q-Reserve, you should choose core facilities, and then you, as I said before, you can create your profile, and then it will be, you can see any tool, any instrument available. So you will have, you can have access to book, to reserve.
Okay, thank you. Thank you, Paulina, for joining us. So let's sum up the session. So Madina, again, thank you very much for coming, for telling about the lab facilities. I think many students indeed did not know about the existing of such machines, such laboratories, and thank you for the provided information. Thank you everyone for joining, for asking interesting questions, for spending time with us in a Saturday evening. So as you may know, all the sessions of the remote lab tour sessions will be recorded and are recorded. So we have uploaded them on our YouTube channel. And if you want to rewatch some sessions, you can just find the Ministry of Research and Innovations YouTube channel and rewatch each session. And please also check our emails and Instagram and Telegram pages. We are going to publish there more and more about the remote lab tour sessions and like basically anything interesting for the new student. So thank you all for joining us. Thank you again, Madina. I think it was really interesting. And please join us in our further sessions, which are going to be conducted following weekend. So it was nice to see you all here. Stay tuned and be safe.
Okay, goodbye. Bye to everyone.
Goodbye. Goodbye, Paulina.